Hello everyone, I am K. Vaishnavi and my teammate is A. Sushma Srivalli Gayatri. We made this presentation under the guidance of Dr. M. Prasad Sir, Associate Professor, Department of CSC. In this presentation, we are going to explain about computer system operations. Well, coming to the introduction, computer system operations refer to a set of activities and processes that occur within a computer system to execute tasks and manage its components. These operations are crucial for the proper functioning of a computer and can be broadly categorized into four main functions. They are nothing but input, processing, output, and storage. And these are the main functions of operating system. They are memory management, device management, process management, security, error detection, coordination between software and user, job accounting, file management. And coming to the basic components of computer, communication unit, input unit, memory unit, output unit, control unit, AL unit, and central processing unit. Now, let us discuss about components of a computer system. There are four core components of a computer system. They are CPU storage, RAM, and I/O devices. CPU is nothing but the central processing unit, and it is responsible for executing instructions and performing calculations. It interprets and carries out program instructions. The storage in a computer system refer to the both long-term and short-term storage. Long-term storage is typically provided by devices like hard disk drives, pen drives, solid-state drives, which can store data even when the computer is powered off. Short-term storage includes RAM, which is used for temporarily storing data that the CPU is actively using. The RAM is a type of volatile memory, mean that stores data that the CPU currently working with. It provides fast access to the data and instructions and allowing the CPU to work efficiently. And the fourth main component is I/O devices, nothing but input-output devices. Input devices like keyboard, mouse are allow users to input information into the computer, and output devices like monitor, printer. From these output devices, we receive the output. These components work together, form the foundation of a computer system, with the CPU as the processing unit, storage for data retention, RAM for temporary storage, and I/O devices for interaction with user and the external world. The next topic is operating systems. An operating system is a system software which provides various services for computer programs by managing the both computer hardware and software. And these are some of popular operating systems. They are Microsoft Windows, Mac OS, Linux, iOS, Android, and Unix. The next topic is boot process. The computer boot sequence is also known as the boot process, which is a sequence of steps that a computer follows when it is turned on or restarted. It is the process by which the computer's hardware and software work together to bring the operating system into memory and prepare the computer for use. Some of the typical computer boot sequence are power on self-test, which the power on self-test is the first thing that happens when you turn on the computer. This is a series of diagnostic tests to check if the computer's hardware components, which are like CPU, RAM, and storage devices, functioning correctly. If the post detects any hardware issues, it may display error message or beep codes to alert the users. The next step is IOS, Basic Input Output System. After a successful POS, the computer's BIOS take control. The BIOS is firmware stored on a chip on the computer's motherboard. The basic input output system contains instructions for initializing and configuring hardware components, including the hard drive, keyboard, and display. It also stores the boot order, which determines where the computer looks for the operating system. And the next typical computer boot sequence is bootloader. The basic input output system loads the bootloader, which is a small piece of software located in the master boot record of the bootable device. The bootloader's primary function is to locate the operating system and loading it into the memory. And the next topic is file systems. A file system is nothing but a method used by computers to organize and store the data on storage devices such as hard drives and SSDs. It provides a structured way to store, retrieve, and manage files and directories. File is a collection of data that stores as a single unit. File can contain images, documents, programs, and more. Directory. A directory, also known as a folder, is a container used to organize and store the files. Directories can be nested within each other and to create a hierarchical structure. File attributes. File system store metadata about each file, including its name, size, creation data, and permissions. File path. A file path is a unique location that specifies the exact location of a file or directory within the file system. And these are some common file systems. NTFS, New Technology File System. exFAT, Extended File Allocation Table. APFS, Apple File System. The next topic is process and multitasking. Process is nothing but a program in execution, comprising of code, data, and system resource. The features of process is process can run independently with their own memory space. The operating system manages and schedules the process. Process can be in various states such as running, waiting, and terminated. And the OS allocates CPU time, memory, and I/O resource to the process. Coming to multitasking. Multitasking is nothing but execution of multiple processes concurrently on a single CPU. CPU time is divided into time slices so that each process getting a turn to execute. Multitasking maximizes the CPU utilization and throughput so that the efficiency is increased. The OS saves and loads their states when the switching happens between two processes. Process can have different priorities for scheduling. Parallelism is nothing but multitasking can be achieved through multiprocessing and multithreading. Resource management ensures fair allocation of resource among competing processes. Critical in embedded systems, ensuring timely response to event. It is real-time multitasking.
So, our next topic is about memory management. Imagine RAM as your computer's short-term memory. It's fast, it's volatile, and it's where your active tasks are alive. We will also explore the concept of virtual memory, which acts like an extension when your RAM is working hard. Efficient memory allocation is the key of memory management. So, to achieve a degree of multi-programming and proper utilization of memory management is very important. Memory management is nothing but the task of dividing the memory among different processes. Main memory is also known as RAM, which is nothing but random access memory. When RAM is insufficient, the operating system swaps the data between the RAM and the storage. Virtual memory uses a portion of the hard disk drive or SSD and as an overflow when RAM is full, which allows the computer to run more programs simultaneously. Memory management techniques are of two types: contiguous memory management and non-contiguous memory management. Again, contiguous memory management technique is divided into two types: fixed partition scheme and variable partition scheme. When RAM is insufficient, as we told earlier, the OS swaps the data between the RAM and the storage. So swapping is a memory management technique used by the OS to manage multiple processes within a single main memory. It's the process of bringing a process into the memory and then temporarily copying it to the disk after it has run for a while. This swapping technique allows larger or multiple processes to run concurrently and but it degrades system performance. Swapping has been subdivided into two concepts: swapping and swap out. Swap out is a technique for moving a process from main memory in the user space to the secondary memory. And swapping is a technique where program is transferred from hard disk to the main memory. Now, moving on to the file management. Think of it like organizing your digital workspace. Directories, file permissions, and different file systems play a crucial role. Understanding these concepts ensure your data is neatly arranged and secure. File management is the process of organizing, controlling, and manipulating digital files within a computer system. Files are organized in directories. Understanding the directory structure is essential for efficient file management. File systems often include features such as file and folder permissions, backup and restore, and error detection and correction to protect data from loss or corruption. Various file systems, example, and NTFS and APFS, manage file storage on the disk. Coming to the importance of file management, proper file management enhances data accessibility and system organization. Poor file management can result in data loss, security breaches, and decreased efficiency. Now, let's talk about input and output operations. This is where your computer communicates with the outside world. From transferring data between the devices to understanding the speed of different I/O devices, it's a crucial part of the computing experience. As we can see here, there are many input and output operations, which are data transfer, I/O devices, data read and write, data transfer speed, and I/O optimization. I/O operations involves the transfer of data between the computer and external devices such as storage, drives, and printers, and network connections. Understanding the mechanisms of reading data from and writing data to storage devices, which play a critical role in file management. Data transfer speed affect the system performance and user experience. Efficient I/O operations are vital for overall system performance and responsiveness, and proper optimization can enhance the user's computing experience. Alright, it's networking basics time. Ever wonder how your computer connects to the internet or shares file with other devices? We will discuss protocols, network interfaces, and the difference between local and wide area networks. Networking is the backbone of our interconnected world. Networking involves connecting computers and devices to share data and resources such as printers, files, and internet access. Common networking protocols are TCP or IP. Understanding the role of network interfaces such as Ethernet adapters and Wi Fi cards in connecting computers to the networks. LANs are used for small scale connections, and wide area networks, which are WANs, that used for span larger than geographical areas. Recognize the importance of internet connectivity and the need for network security measures to protect data during transmission on from external threats. Troubleshooting addresses common computer issues. Diagnostic tools help identify problems, and understanding software and hardware troubleshooting is essential. Regular maintenance tasks like updates and backups keep the system reliable. Security is crucial for protecting your computer. Antivirus software detects and prevents malware, while firewalls acts as a barrier against unauthorized access. Understanding various security threats is key to implementing effective protection measures. In conclusion, we have explored the fundamental aspects of computer system operations. Armed with this knowledge, you are better equipped to navigate the complexities of computer systems for an optimized and secure experience. Thank you.